In this lesson, we're given the graph of a quadratic function, otherwise known as a parabola. You can see here I have 1, 2, and 3 separate graphs of different looking parabolas. The goal of this lesson is to be able to identify what's referred to as the roots of the quadratic function. Now, roots is a term that we use to describe the x-intercepts, or where we touch the x-axis. The x-axis being the horizontal axis. And so there are 3 different cases where we can have x-intercepts. In one case, we may have what we call 2 of them, or what we would say here, there are 2 roots. There is one here where we touch the x-axis, and a second one here where we touch the x-axis. Both of those are points written in the form x comma y. This point on the left might be at like -1 comma 0, and this point on the right might be at, say, 4 or 5 comma 0, depending on the tick marks. Again, roots are x-intercepts. And because the height of those points is always going to be 0, we know their address is going to be x comma 0. Therefore, they are oftentimes referred to as the zeros of the function. So if you ever encounter a problem where it asks you to find the x-intercepts, or the roots, or the zeros of a function, they are asking for the same thing. A second case would be a parabola like this, where the vertex touches the x-axis, and there's only one root. Again, in this case, we would have x comma 0, maybe 3 comma 0, as our only root, or our only x-intercept, or our only 0. In our final case, we have this parabola, and in this parabola you can see there is nowhere this red parabola touches the horizontal x-axis. Therefore, we would say there are no roots. As you get older and you learn more about roots and x-intercepts and zeros, you'll find that the correct answer is that there are no real roots, and instead there may be imaginary roots. But that's a lesson for another day for Algebra 3-4. All right, so just to recap, if we're asked to find roots, that means finding the x-intercepts. Look where your graph touches the x-axis. Write your answer as a point where the y value is 0.